Good afternoon, distinguished colleagues. Just as it was mentioned in the last session of this session, project efficiency and operational efficiency are intricately connected. And I will speak about both sides of the story. And we have mentioned certain points regarding human resources and innovations. I will make more focus on people and organizational innovations, because without those, not a single technical innovation would work. I will start with a certain slide regarding projects. That is the analysis of the company of independent project analysis, which monitors thousands of projects throughout the world. What it tells us, those are normalized from $1 billion of source budget, and the best quartile end up with the total of 750 million, that is below the budget. Fourth quartile on average is 1.7 billion, so their budget overruns is 70%. And apparently there is the correlation. Quartile 1, 27 months projects, 2 years and a bit, and in fourth quartile, 5 years and more. So why such radical changes from the monetary point of view that predicates the competitiveness of that in the market? The world is changing very rapidly now, and the only thing which is guaranteed is that the changes are guaranteed, nothing else is. Even in our core business, we sometimes fail to keep track of new things emerging, and that could have a radical impact on how and when to do one's next project. 20 years ago, there were changes, but not that much of a change. If you remember how we did projects 5 years ago and now, we could appreciate qualitative changes. But even if all the party of the project is ideal, in any case, there is the issue of interfacing at an early phase. Because when we do automation in a certain way, we can do the construction bit differently and the technology bit differently, and our suppliers and vendors can operate differently. Therefore, doing the decent job of organization of the project work at early phases becomes an absolute key. Thus, such radical economic differences between the quartiles 1 and 4. Then all that goes into the phase of operation. And this is just an example of how equipment should be selected. During operation, this issue becomes even more important than in the design. That is the example of a global petrochemical company which has operations in virtually all the continents. We sat down and calculated that valves of various types account for 40% of cost during operation. That is the cost of the valves. All the rest is the overheads of the global petrochemical companies, warehousing, professionals for various types of equipment, bureaucratic procedures for purchasing, tenders, and so on and so forth. So if we add all the overheads together, we end up with this kind of findings. And we work with them to standardize that. The project has started quite a long time ago, and now more than 70% of all procured valves for all the operations in all the continents are standardized, and more than 50% of them are delivered from us to production facilities from centralized storages within 2 hours. We have certain level of inventories at warehouses throughout the world. That is the example of how the choice of equipment impacts the efficiency. And I would like to run a short poll regarding equipment unification. 3 options. Please rewind, and I will explain what the question is. Option 1, EPC contractors and design institutes choose equipment and get the end user confirmation. Second scenario, the end user unifies equipment for particular units or parts of the project. And the third option is when the end user unifies the equipment for the entire project, taking into consideration new technologies and operations and experience from existing production facilities. That is important for reliability. Let us run the poll, if I may. The question is how it is happening now. Right? That's it. Let's wait a bit longer, about 30 seconds. So far only 5 people voted. Essentially, this is just one of the examples of how one can do projects differently, and the example of impact onto the economic parameters. Okay, 10 people, or 13 statistically important things are emerging. 70%, that is option 1, when there is a certain kind of zoo in the project and it is not very clear how to run it next. But there are some positive shifts. Out of the 20 votes, 30% favor best practices, which is a joy. Let us go back to the presentation and I will continue with my line of thinking. So using our example, first of all, your equipment should be reliable and accurate. In our case, accuracy is good. I can assure you of the following. Just as in the car, whatever math you might have in the world, if your tires are not good enough, you will find yourself somewhere in the ditch. So from the point of view of automation, it is absolutely paramount to be still connected with reality. Installation of the sensors are important. If the sensor are not calibrated in the right way, that becomes important. Up to 40% of new models per year focus one key thing: to make it flexibly adjustable to the changes in your requirements and your processes. That is critical for the design and then in the process of operation. Going back to the issue of standardization of equipment and the balance between the final user and the EPC contractor, we shouldn't look at this as the equation with zero results. That doesn't mean that everything gained from the vendor is the profit. Without going into details, if we are to implement cutting-edge engineering practices on top of that, we could achieve the positive economic effect for both end users and also design institutes and the suppliers. The companies should work as one team and then to share the result. If you first share and then try to do something, there will be nothing to share. Now, a couple of more cases where this concept is used. Standardization across all the projects, that is option 3. Monetization of gas is our core thing. 2 largest projects in LNG in terms of tonnage is the one in Qatar Gas, and world's largest FLNG of Shell. That is a complex R&D and technical undertaking, and from that point of view, strategic partnership becomes paramount. Without that, it is impossible to do such large projects, and equipment was designed specifically for the project, starting from the R&D. In oil and gas chemistry, I can assure you that the concept of standardization throughout the process was used in those projects throughout the world. In Russia, since we did the poll, primarily that is relevant for production. But in the processing domain, there are certain achievements. I have in mind Yamal LNG and Vysotsk LNG. This is not exactly the core topic for those of you here, but the principle can be adjusted for the gas chemical use in exactly the same way. The Vysotsk LNG is the first LNG project in Russia to use the entire standardized automation. Means we are partners with Nipigas and others. And starting from valves and control and measuring equipment and the system of management and control, all the way to simulators. That is what colleagues from STEMI Carbon mentioned. The model of the technology process, so the digital twin is also used. And the first cargo of LNG was loaded not very long time ago. In Yamal, the situation is different. It is classic example of option one. When EPC contractors from all over the world send their people there, they see great variety of approaches, and we have to have quite a large number of Russian engineers to deal with issues on the spot. First of all, commissioning it with deadlines, which are yesterday, operating it in the Arctic conditions, and then if there is something associated with reliability issues, they need diagnostics and so on. We did all that in the first two lines in Yamal. Now train 3 and 4 will be built, having in mind the actual operational experience we have accumulated. Essentially, the point of that digital revolution we have been talking about 5 to 10 years ago, we didn't measure certain parameters. Now we can measure those quite efficiently. This is just the example of valves, and the measurements we can take allow us to see when and what kind of problems will most likely occur. And therefore we can be proactive in rectifying the situation, and we can resort to various measures, and if we cannot do without maintenance, we can do maintenance focusing on several units simultaneously, and this is what it leads to. Together with the organizers of this conference, we visited a refinery which also had a base chemicals business component. For 10 million tons per year, they employ 400 people of members of staff. For Russia, this is quite unique. In Russia, the average headcount for such operations in Russia is 5 to 10 times higher. And it's not only the problem of payroll, it's worse than that. Such a great number of challenging pieces of equipment mean that members of staff are not always knowledgeable and cannot deal with those pieces of equipment in the optimal way. And that means competencies with such high-tech pieces of equipment are very important. And our Russian colleagues asked our Austrian colleagues as to how they managed to achieve that. The answer was that all the key categories were standardized, and for the time of maintenance, we basically have 260 people of permanent staff going on vacation. Then we sign the contracts for diagnostics. The contractors monitor everything which is possible on a remote basis, and when we have to stop the facility for maintenance, we maintain everything possible. Therefore, Europe was surviving at the refining margins of $2 to $3 per barrel. We were basically chuckling at that in 2012 and 2013, but now we appreciate what was behind that. And of course, the devil is in the details. It is easier said than done, and starting with the assumption that all the production facilities are different. Apart from processing, there is production and transportation, and based on that and having in mind the certain parameters, we have to provide all kinds of solutions. Downhole and wellhead automation, all that has to be integrated and adjusted for a specific purpose. That is especially true for the vertically integrated companies. They have the complex chain of adding value, and we should look at that in its entirety. Another relevant organizational experience of doing the job at a brownfield and taking it from now to the target situation. Many have already experimented with that. On the x-axis, we have normalized maintenance and repair cost per $1 billion worth of assets. And in vertical scale, we have operational availability, and the leaders of the industry have it at about 97%. With a cost level of about $120 million per $1 billion worth of fixed assets. A European company experimented with that, and the straightforward way, basically, which leads to hell, is to cut costs and change nothing. Let us cut everything now. We do the cutting on the members of staff, we do less maintenance and inspections, and initially it is even regarded as helpful. They were going to that point, and they made it from 2010 to 2014, but then a fire broke out, and they had basically to return to the point which is worse than their initial starting point, because the crude unit fire and steel reforming unit failure. So there are many ways to do it differently. For instance, why wouldn't they resort to diagnostics? But that requires the changes in the organizational structure. One shouldn't think that innovations is something which is delivered by a wave of a magic wand. No, far from that. Changes have to be made in ways of doing one's business and operating. No innovations will ever be performing if people do not perform in a different way using such innovations. So we purchased a consultancy, which is now part of our perimeter, which focuses on reorganizational consulting around the innovations. Just to emphasize, that is a very important aspect. When one comes from design to operations, people are all important. Changes are driven by people, and primarily those are departments of operational efficiency. I have about 90 business cards from people who are heads of departments of operational efficiency. They get paid if the economic parameters of the business are increasing. They could be external or internal to the perimeter of the company, but their activities are paramount for success of the business. So a couple of minutes about our story and our people. We have started doing business in 2004, not 2014, but 2004. Now we have the largest headcount out of the entire range of companies of our domain of 1,500 people. And starting 2004, we have been doing that because of economic considerations, using the key Russian advantage, that is programming engineers of highest level. We purchased a relevant company in Chelyabinsk, and the guys were winners of international contests. That is our principal economic advantage, which enabled us to do everything else in Russia. So without people, there wouldn't have been nothing. Now we are building the second train of the plant of our fabrication facility, and up to 80% of all the pieces of hardware we offer for Russian projects is made in Russia. Starting 2014, we went even further into localization spin, and by 2015 we would manufacture all those types of equipment, all kinds of valves, drives, and so on. And the last slide, which focuses on localization. Our engineering center of 100+ engineers does the R&D for the entire global operations. If something they come up with is efficient, it is used throughout the world. That is especially true for low temperature options, small size instrumentation, sensors. They were developed in Chelyabinsk, patents were taken out, and now they're used throughout the world. And our team of engineers enabled us to localize fabrication and production in a smart way. Not everything and always should be localized based on economic considerations. And so, wrapping up my story, in terms of localization, what we do, we decrease the share of imported components. Now it is less than 25% in the price of the equipment, and to deal with sanctions risks, we refocus to Southeast Asia for diversification in terms of procurement. That is all. I think it will be useful for your projects and operational issues. Thank you.